Okay, so this is the final hole on the second planet. The hint is telling me to observe how spin can affect the path the ball will take during its flight through the air. So this is a nice progression because we've been scaffolding these concepts as they go along. They're constantly building off each other. We started on this planet with just the new forces, and then we saw how we can take those forces and add them and get the net force. And now we're actually seeing what the spin with an atmosphere layer will affect the flight path of the ball. All right, here we go. All right, so I've got a nice power up right here. Earth-like density, which means the driver would be a good choice. It's probably gonna bounce and roll a little bit. So we have some wind. It's a forward wind, which means it's gonna carry it just a little bit. So I'm just gonna hit it straight on right here with this amount of energy in it. See how it does. Okay, so right here we're seeing the visual for airflow, and this is a good time to bring up where lift comes from because it is generated through the backspin of the ball. The dimples are really reducing the drag, which in turn will affect the net force, which can cause it to go farther. But as far as the lift goes, is really from the flow of air particles over the ball. You're going to have a lot of friction occurring, and over the top, you'll notice that the particles are moving substantially faster because the ball, as it's spinning with a backspin, is almost catching and dragging and creating these small pockets of low pressure zone, pulling those particles into it. Now the bottom ones, they're getting thrust and slowed down and pushed into the center. So you get this nice little push underneath it, and that's where the lift comes from, is the difference in pressure. There has been talk about the Bernoulli effect as being the primary theory as to why this happens, but I would be hesitant to talk about the Bernoulli effect just because a lot of the equations, much like some other aspects, as you can get into like convection for plate tectonic movements, there's a number of theories that exist, but none of them have really been defined into laws. So I would be hesitant. It might be worth a mention, but I don't know if I would focus too much on the Bernoulli effect as a primary cause. Here we have some extra telemetry labels like fast-moving particles, dimples. We have dimples, and this actually is going to cover about the average golf tip. It's going to talk about how many different dimples are on the average golf ball, and also what the effect is that they have on lift and drag. And again, you can click on the Wikipedia article that has a link in there. Not bad. That just happened. That just happened. Birdie on the third hole. Never done that before. That was amazing. Okay, so let's take a look at the final question for this planet. What does spin cause the ball to do on a planet with an atmosphere? Okay, so spin has no effect on the flight path of the ball. We definitely know that's incorrect because as soon as we were able to put spin on the ball with the different path that the club can take and as well as the facing angle, we know that that's going to put a particular spin axis on the ball which causes it to curve in a different place. So the ball can curve without spin. This is an ambiguous point because can you ever really get a ball hit that doesn't have spin? So this may be an outlier distractor. Spin causes lift and can allow the ball to curve. This actually sounds exactly what we're looking for. Backspin decreases lift, it actually increases lift. We know that. It would take forward spin to decrease lift. The atmosphere does not affect the flight path of the ball, only spin. Well, if you didn't, that would say that if you didn't have atmosphere, then spin could have any effect, in which it doesn't. So I'm going to put this one to see if it's right. It is.